Hello everyone, welcome to LO007 Warehouse and Inventory course video with me Fandy Bestario Harlan. In this video, we will continue discuss about aggregate planning in a supply chain with a special discuss about aggregate plan case study. The learning objective of this video is to solve and calculate basic aggregate planning using Microsoft Excel. Okay, here we have an example of a complete informal aggregate plan. Can be seen in table next slide. This case is an example of utilizing a level strategy. Assume that employment levels and output levels remain constant, while inventory is allowed to build up in earlier periods, only to be drawn back down in later period as demand increases. Also, note that back orders are utilized in order to avoid overtime or subcontracting. And the question is, calculate cost for the individual variables. So the first step, we should be analyze the table provided for this case. Here we have 6 periods in a row with forecast of each period shown in this table. Period 1, 100 until period 6, 150. Then the output production of each period is remain constant, which is 250. And here we only using workforce in regular time, so we can ignoring for overtime and subcontract. So we can find that output minus forecast of each period, which is this used for how many output that utilizing in each period. But here we can see that production output of some period is negative value. It's mean that demand forecast of that period is surpass output production. Then we can see inventory that used for anticipate the demand of the period. Here we can focus on period 5 because in period 5 we have deficit inventory. We only have 150 in inventory, whereas we need 250 to fulfill the demand. So the shortage of 100 products can be used as a backlog in period 5. And backlog will be fulfilled in next period. Okay, so here we have some unit price data. In regular time, we need $5 per unit to production. In overtime, we need $8 per unit. Using subcontract, we need $12 per unit. And the other costs, such as inventory carrying cost, $3 per unit per period. And back order cost is $10 per unit per period. So with the data above, we can calculate of detailed cost of this aggregate planning for 6 period using level strategy. In regular time, we have $5 multiplied by 1,500, which is total production in 6 period, and the result is $7,500. And the overtime cost and subcontract cost is $0. And the other cost, we have inventory carrying cost that is $3 multiplied by 850, which is the total inventory in end period. And the result is $2,550. For back orders cost, we have $10 multiplied by 100. Then the result is $1,000. So we will sum of each cost above, then total cost becomes $11,050. That is the scenario 1 for aggregate planning using level strategy. And then we will compare strategy in case 1 with strategy in case 2, where a second example shown in table below presents the same scenario as previous example, but demonstrates using of a combination strategy. That is combination of level and chase strategy to fulfill demand and minimize cost. For this example, let's assume that company policy prevents us from utilizing back orders and limits our plan to no more than 50 units of overtime per period. We use level strategy, which is regular output level is constant, implying a level workforce. And we use chase strategy, which is overtime and subcontracting are used to fulfill demand on a period by period basis. Here we have forecast demand as same as previous example, but we have constant output production that is 200 unit in regular working hours, and we use overtime working hours in period 4 and 5 with limitation 50 unit. We can focus here in period 5, which is to fulfill 500 demand. On period 5, we need subcontract workforce to production 250 unit because we have 0 unit inventory and only production 250 unit in regular and overtime working hours. So if we calculate the output cost of this scenario, cost in regular time, we have $5 multiplied by 1,200, which is total production in 6 period, and the result is $6,000. And then cost in overtime, we have $8 multiplied by 100, which is total production in period 4 and 5, and the result is $800. And then cost in subcontract workforce, we have $12 multiplied by 250, which is production in period 5, and the result is $3,000. And for the other costs, such as inventory carrying costs, we have $3 multiplied by 350, and the result is $1,050. For back orders cost, we have $0, and the total cost of this scenario is $10,850. So here we have the conclusion that using combination chase and level strategy in case number 2 would be minimize operation cost for 6 period ahead compared with only using level strategy on case number 1. Okay, that's all the explanation regarding aggregate planning in a supply chain case study. See you for another discussion in next video.